Okay, hello grade 12. This is the November 2017 question on internal resistance. It says, learners investigated the relationship between potential difference and current for the combination of two resistors R1 plus R2. In one experiment, resistors R1 plus R2 were connected in parallel. In a second experiment, resistors R1 and R2 were connected in series. Okay, so before we go any further, let's just discuss R1 and R2. The resistance in series of R1 plus R2 is always going to be bigger than the resistance in parallel of R1 and R2, because remember that resistance in series, the resistance gets bigger because you add them together. But for the resistance in parallel, the relationship is more complicated because 1 over R parallel equals 1 over R1 plus 1 over R2. Okay, so the resistance in parallel, resistance always is less for a parallel circuit than for a series circuit with exactly the same resistors. So we must think about that before we do anything. So the learners then plotted graph X. Here we go, the result of one of the experiments. Can you see here is graph X, and graph Y, the results of the other experiment as shown below. So it says to you, state Ohm's law in words. That's easy enough. The potential difference across a conductor is directly proportional to the current in the conductor at a constant temperature. Remember, the at a constant temperature is always important. Now it says to you, 9.1.2. What physical quantity does the gradient slope of the graph represent? Well, we know from Ohm's law, look, there was a hint in the first part, R equals V over I, and this graph is plotting voltage against current. So the gradient of this graph, if you have a look, will be voltage over current. So this is going to be resistance. Now it says to you, calculate the slope of graph X. So I'm going to use this point here, 3 and 0,75 and 0, 0. So my gradient formula equals the change in Y over the change in X, which is 3 minus 0, because look, 3 off the top there, 0 at the bottom there, over my x-axis, this was 0,75 minus 0. So 3 over 0,75. Remember, you have to show your zeros. If you don't show your zeros, you're going to be in trouble. Okay, so show that you didn't just take a point, show that you took the gradient and you subtracted 0. So my gradient, 3 divided by 3/4, gives me 4 ohms. The gradient of the graph is 4 ohms. Now it says to you, for 4 marks, determine the resistance of resistor R1. Okay, so if we have a look at this graph, can you see that we actually don't have a lot of information about the two resistors? All we know is that we have a parallel resistance and we have a series resistance. Okay, so from the gradient of the graph that we've calculated, if you look at these two graphs, X has got to be the series resistance because it's got a steeper gradient, which means the resistance is higher, and series resistance is always higher than parallel resistance. So we know that in a series circuit, okay, the resistance in a series circuit will be equal to R1 plus R2. So the resistance in series is 4 ohms. Okay, we got that from the gradient of the graph. So we can use the gradient of graph Y to tell us what is the parallel resistance. The gradient of graph Y is the parallel resistance because parallel resistance is always less than series resistance. So what would the gradient of this graph be? I would take it at this point over here. Okay, so I would say 0,5 minus 0 over handily 0,5 minus 0. So a half over a half is going to give me 1. So from these two gradients, R series is 4 ohms, okay, and R parallel is 1 ohm. Okay, and R series is R1 plus R2. R parallel, we know we've got that nice formula. R parallel is 1 ohm from the gradient, and then we know that we've got product over sum. So R1 times R2 over R1 plus R2 is going to give me 1 ohms. Remember, this is the simple formula. But have a look here. In series, we were adding R1 plus R2. So we can actually substitute this 4 immediately into this equation. So 1 ohm, remember that's the gradient, equals R1 times R2 over 4, which means R1 times R2 equals 4. Okay, so now there isn't any other information, but what if this is the same value? We have to figure out, if you think about and do the maths, 2 times 2 equals 4, and 2 times 2, 1 over 2 plus 1 over 2 gives you 1, which will give you the parallel resistance. So the most logical thing here is R1 equals R2, and they are both equal to 2 ohms. Okay, just if you're confused, pause the video and think of all the factors of 4, because they have to be factors of 4 if R1 times R2 equals 4. And the most logical factors of 4 that it can be to give you the values 1 and 4 is 2 ohms. Now it says to you, the circuit below consists of 3 resistors, M, N, and T, with a battery with an EMF E and an internal resistance of 9 ohms. Okay, I'm just writing it bigger because I can't read in my tiny diagram. It says to you the effective resistance between points A and B. Okay, so this thing over here, which is M plus N, the effective resistance between points A and B in the circuit is 6 ohms. So that means M plus N is going to equal 6 ohms because they are in series. It says the resistance of resistor T is 1.5 ohms. When switch S is closed, okay, so the circuit is complete, a high resistance voltmeter V1 across A and B reads 5 volts. Okay, so here, this voltmeter here is reading 5 volts for M plus N. It says calculate the current delivered by the battery. Now current is the same everywhere in a series circuit. So if I know the voltage across those 2 resistors, and I know the effective resistance, which is when we pretend that it's only one resistor, the question says to you the effective resistance was 6 ohms, okay, and the volts were 5 volts, okay. So we can substitute into the formula because we know M plus N equals 6 and the voltage is taken over both of those resistors. So the current is going to be 5 over 6, which I do believe is 0.83 amps. It's like 0.83 recurring. Okay, so then the current is going to be the same everywhere in this circuit at the end of the day because it's a completely series circuit. Now it says to you calculate the EMF of the battery. So we know that the EMF is equal to the current times the external resistance plus the internal resistance. So we're trying to find the EMF. We know the current is 0.83. So what is the external circuit's resistance? Remember, it's a series circuit. It's M plus N. Can you see M plus N plus T? We know M plus N is 6. It told you in the question. We know that T is 1.5. So that's the external circuit will be 7.5. Plus the internal circuit, they said to you that was 0.9. So if you work this out, 7.5 plus 9 gives you 8.4 times 0.83. You end up with the total answer here being exactly 7 volts if you kept the 0.83 in your calculator. So the EMF of this battery is 7 volts. Now it says to you voltmeter V2. Okay, look here. Here's voltmeter V2 over here. Voltmeter V2, which is only over the resistance M, reads 2.5 volts. So this is 2.5 volts on this voltmeter, and then this voltmeter V1 was 5 volts. So it says to you, voltmeter V2 reads 2.5 volts when the switch is closed. Write down the resistance of N. Now, what do we know about a series circuit? Okay, in a series circuit, the potential is divided. A series circuit is a potential divider. So I have got 5 volts over the 2 resistors, okay, and then I've got 2.5 volts over little resistor M. 2.5 is exactly a half of 5 volts. So the voltage is splitting in the ratio of the resistors. So if this is half of the volts, then this is the other half of the volts. It means the 2 resistors must be exactly the same. And in the beginning they said M plus N is 6. So what is half of 6? Is 3. So M is going to be 3 ohms. No calculations required. And then I think it said explain your answer. So the explanation for the answer is a series circuit is a potential divider. The resistor, this voltmeter, has exactly half the voltage of the 2 resistances, which means that the 2 resistances must be identical, and a half of 6 is 3.